Now let's have a look and see how we're going to design in a keyboard, a display and a graphics unit. Now in this video we're going to look at the keyboard. The best way of doing this initially is to actually just have a little play with a keyboard. So I have the keyboard here. Now if you want to get the keyboard, you just head into the input output and you'll see that there's a keyboard here and you can just grab it and drop it down. Now we can see here, if you hover over, it tells you this is the clock, so it's going to clock in out values from the keyboard. We have a button here which is a read enable, which allows the outputs to actually be read. Okay, so whenever it goes high, the outputs can be read out. We've got another one here which is a reset, so it's a clear as 1, so basically it just clears or resets the keyboard. We've got another one in here which is 1 when the buffer contains a character, so whenever there's a character within the buffer of the keyboard, that will be high. And finally we've got the ASCII output. So let's have a closer look and we'll see how this works. So there's the keyboard here. We can see here that it gives us either a 7 or an 8-bit ASCII output. So we'll just keep that at 8 bits. So remember, the ASCII output is just a recognised number to represent each of the characters. So ASCII, American Standard Code for Information Interchange, that's what that stands for. Now we'll have a little play with it and we'll see how it works. That's probably the best way of going forward. So first of all, we can write things into the keyboard, and it jumps directly from your keyboard into this keyboard here. We can clear it or reset, so we click on that and it just resets it. So that's relatively straightforward how that works. Now the other thing here is the buffer. So as soon as you put anything into the keyboard, that goes high. Okay. Now if there's nothing in the buffer here for the keyboard, if you like, the buffer's like just a little bit of memory that stores the values that you've typed in. So if there's nothing in the buffer, that will just go low. So that's a handy thing to be able to know whether the buffer has got anything in it or not. Now the output here is the ASCII for the value here. So if I had a capital A, this is going to give you the ASCII output. Now what I could do is I could put a little probe on this and we could actually see the value in a normal integer value. Okay, so if I put that value up here and I change this to octal signed unsigned decimal. Okay, so you can see here that the letter A has got the ASCII value 65, which in binary is this value here. So if we were to save this value to somewhere in memory, then we know that or we could interpret that number as the letter A. Now I'll have a list of the ASCII code and you can have a look at that. I'll leave that in the resources section. So this is the basics of how it's going to work. Now we want to actually see how we can read stuff out of this. So if I was to write in, for example, hello world, now I could clock this in and out, and if I clock that, you see there's absolutely nothing happens. It will not clock out until the value here has gone high. Okay, so once that has gone high, it will allow us to clock out, and we can see here that we've chosen it's going to trigger on a rising edge. So on the rising edge, when I click it, this H should then disappear. So you can see that the H here is the actual ASCII code that we've got sitting here at the moment. So that's the ASCII code and the decimal for it is 104. So whenever I clock this, you can see on the positive edge triggered, that H has disappeared. So now the H has jumped out of the buffer and the value of the output here is now 101, which is the ASCII code for the E. And then on the next positive trigger, the E will jump out. And we can do this and keep clocking these, and we can clock these out. Now, we aren't able to clock these out unless this value here has gone high. Okay. And that's the basis of the keyboard. So what we want to do is we want to take this keyboard here and we would like to add it in to our design. So you can see here, I've actually got the keyboard sitting here. And we've got the required inputs here, okay? But let us talk our way through this. Now, first of all, we'll go down to the lower level. So it's really at this level here that we want to define all our inputs and outputs. Now, what we mean by an input is something that passes information into the CPU. So a keyboard, you type in, it passes that information into the CPU, so that's an input. Now, after we do this video, we will look at the display, and the display is an output. So once we've put the values into the computer can mess about with the values and it can output it to the display. So we're interested first of all in the keyboard, and you can see that I've chosen a particular input device here for the keyboard. Okay, so this has just been, and I've just called it keyboard. So we've seen these before. This is our memory mapped I/O. So if I go into just one of these, you can see we've got this sort of set up here, and we've talked through this in a previous video, but we will go through it here as well. So it means that what we want to do is just treat the keyboard as a memory location. So using memory mapped I/O, if we know the memory location of the keyboard, then we can simply store information. So that is, we can load information. That is, we can take the information from the keyboard and we can bring it into a register. So we can use the load command, and if we use, say, load and we have the memory address and then the register value, then when it sees that memory address, it actually knows that it's going to go to the keyboard, and it will look for that information at that point because we've used that memory mapped I/O. But we'll see that working just in a minute. So what does it look like in here? Well, just the same as it did with the general input device. So let's quickly remind ourselves how this works. So if we start off with this EN pin, so EN is for enable. Whenever this goes high, we know that we're going to be pointing to one of the 16 possible I/O devices, as opposed to the RAM or the ROM. And again, you can look back at the memory mapped I/O videos to remind yourself of this. So that really tells us that, yes, we want to talk to one of the I/O devices. Now, the next part here is, which one do you want to talk to? So in this instance here, we're going to use this here as the ID for the device. So at the moment, this device, the ID is all zeros. And this line here, the in address, is what actually chooses this device. So if we were to get all zeros coming in this line here, then this point here would go high. and it would be saying, yeah, we're actually going to choose this device. So let's make these all zeros, and you'll see this point going high. So they're all zeros, this point is going high. So this tells us we're going to look at one of the 16 I/O devices, and this part here says we're actually going to look at this one. Now, strictly speaking, this little EN is not strictly required, but we're just going to leave it in anyway as it is. So now we know that we're wanting to talk to this device, which is the keyboard. We want to talk to the keyboard. Now, in order to talk to the keyboard, what do we mean by talk to the keyboard? Because that's just English language. What does it really mean? Well, what we want to do is whenever we type on the keyboard, we want to pass the data from the keyboard into the CPU. So that is, we wanting to take the data from one place, which is the keyboard, and we want to pass it through to another place, which is going to be the output here, which will be feeding into the CPU. So what we have to do is clock that information through a register. So if you like, the register's a little holding pen. It has the data from the keyboard coming in, but it won't do anything until it has been enabled onto the bus. And when it gets enabled onto the bus, it then feeds into the input of the CPU. Now, in order for it to pass that information into the bus, what we have to do is we have to enable this register. So when we enable this register, it will pass the value which comes from the keyboard out onto the bus. So let's just enable that now. So you can see when we've enabled that, we're going to pass this value onto the output. And that's really the basis of this keyboard input. The EN controls whether we're talking to the ROM, the RAM, or in this instance we're talking to the I/O devices. This determines which I/O device it is, and then this just clocks the information through the I/O device. In this case it's the keyboard, and it clocks the information from the keyboard out into the bus, and from the bus it will just go directly into the CPU. So let's look at this in the next level up. So this is us one level up, and we're looking at the keyboard input device here. Now again, we've talked through this general setup within the memory mapped I/O videos, but we're going to have a reset here, which just goes down and resets everything in the lower level. We have our ID. Now the ID here was the ID for this particular device, and as we mentioned, this is ID 0000, so we've just got a 0 in here. It's just telling us that this input device is going to be device 0, as opposed to this input device here, where you can see is device number 1. And then we're waiting for the EN, so this is the enable here. So whenever this enable goes high, it tells us that we're interested in talking to one of our I/O devices. And then the address comes in here through the address bus, and the address bus will tell us which device we're actually interested in talking to. So we'll get this address from our load command, and you'll see this working, so don't worry about it if you're not quite getting it at the moment. We'll see it physically working. So we'll get this address from the load command. Now we're going to take the least significant 4 bits of that address, and it's going to tell us which value, which I/O device we're interested in. So whenever it comes in with the 4 least significant bits, all zeros, we know we're going to be talking to this device here. So now what we want to do is we want to enable the value from the keyboard into the CPU. So in order to enable the value, well, the data has to come from the keyboard. So it comes from the keyboard via this here. So that is just an input, and that input comes from the top level. So we'll go up to the top level just in a second and see that. But that's basically the input from the keyboard coming from the top level, and it comes into our device here, but it won't pass through onto the bus. And there you see the bus here. It won't pass on to the bus until we have a clock enable. So the clock enable is going to come from the control unit, and it's going to enable the information from the keyboard onto the bus at this point here. So when it comes onto the bus, you see it comes up along here, and it's going to go to the data bus in. So that's the bus coming into the CPU. So the information runs in this direction, down through the top level, down through into this level. Down on the top level of the keyboard, you press the keys in the keyboard, it comes down through this level here to the input, it hits the little register that's in here, and it's waiting for the enable to pass that information onto the data out, which passes it into a memory location or a register, depending where your load command points to. So that's the basic setup here. Now, one other thing to note here, we've got another output that says keyboard clock. So let's quickly drop inside and we'll see where that comes from. So that value comes from here, which is, I've called it IO_enable. So we know that whenever we're talking to this particular device, this line here has to have gone high, and it enables the information from the keyboard onto the bus. So at that point, we have to then decide that we want to clock the information out of the keyboard and onto the bus. So we can use this line here as a little clock to clock that information in and out, and we'll see that in the top level. So let's head up to the top level and we'll show you where that goes to. So actually I'll go down in here first of all, just to remind you. So that's it coming out here, it's keyboard clock. What can you see here? Move over a bit. So it's coming out here as keyboard clock. And finally it heads off on an output, which is just called keyboard clock, which is actually down here. I'll just shift this up a bit so you can see it. So you can see here the keyboard clock, and that's the output, and that just goes to the top level. So let's head up to the top level and we'll have a little look and see where that heads into. So I can open these out a wee bit so you can see them a bit better. So this is the keyboard clock here. So this is us heading in, and remember, nothing will be pulled out of this buffer unless this point goes high. So in effect, this is kind of, it's allowing it to be, the information to be clocked out of the buffer, okay, and then onto the bus and into the CPU. So whenever this goes high, it will allow the values here to be taken out whenever this clock set goes high. Okay, so that's the basis of how this is working. I'll put that back, and we've got the clock set coming in here for the clock. We've got a reset. The in1, now this is the output from the keyboard, and the output from the keyboard is going to come along, and you can see here, if I make this a little bit smaller, the output from the keyboard here is your ASCII output, and it's comes in here and goes to the in1 here. Okay, so that's the in1 to the CPU, and when we follow that down, that comes along here, and this is the in1 here. So that's the route down into the little buffer that we use to buffer the information from the keyboard onto the bus. So that's the basic setup for the keyboard. Let's go ahead and we'll look at an example of actually using the keyboard.